So for these notes, go ahead and you guys can ask them to be paused, or you can, pause them as you need to. But let's go ahead and look at this as we go on. You should have these copies. Either I emailed them to you, or I had some outside my office for if I wasn't able to get somebody to cover my class. But either way, you should have a copy of this. But let's just look at statistics. And I love the way this book does this. They kind of introduce why. I mean, what's the purpose of this class? And I cannot tell you. There's been a few classes in my life that probably had a larger impact on my perspective. Biology was one. And I don't use biology all the time, but I have a general knowledge of how things work and how things interact, and that has changed my perspective on the world when I look at things like, conservation, and I have that knowledge and that science, and I want to protect things that protect each other. Health, and I'm not the healthiest person, but I do keep that in mind, and that class was the reason I stopped drinking, sugar sodas. It just changed my perspective on things, and I thought, what am I doing, Statistics. Statistics is one of those classes that can have a huge impact on your life, because you're looking at this, and people do this. They manipulate data with you all the time. So the idea is that there's a lot of things that we can manipulate correctly and draw analysis from correctly. But a lot of times the way statistics is used is people will take one little piece and use it out of context, or blow something up and really manipulate populations. And that's really scary, which is why we require this class. We want you to have a good set of knowledge. So here's a type of study that I saw pop up where they asked, have you ever been hit with a computer virus? And they pop this up, and you look at this and go, oh my gosh, everyone's getting this computer virus. I need to be nervous. Do I have my antivirus up to date? Right? And this looks like, oh my gosh, it's like, what, 4 times as many people have been hit by a computer virus than not, right? Well, what happens, though, is if you look on the side, a lot of times they'll have these little numbers written on the side, and we don't look at that. We just look at this and go, dang, this looks 4 times bigger, right? Well, what if we saw the numbers here at 60, 80, 100, and 120? You're like, well, yeah, but still, 60 said yes, and 120 said no. That's still a big difference. Yeah, but look at the manipulation here, right? This is what we would call a bad graph. In fact, when we get to the chapter where we're graphing, you don't graph like this. You don't shrink. You don't shrink the y-axis. And so the reason why is because if I was to put this kind of in the real set, if I made this 60, if I did 20, 40, 60, and made that no that high, 80, 100, 120, and that one that high, yeah, it's still bigger, but it doesn't look nearly as large, does it? See, they manipulate. Phone companies do this all the time. They'll look at data and they'll go, look, we have 52% coverage, and they only have 48% coverage, and they make it look like it's huge, and it's manipulation. And that's one of the blatant things that we can see, and that's one of the things that I have a lot of students that will try to do that with graphs. That's a bad graph, and it's a way to manipulate statistics. So write that down, but that's kind of the idea of what we're doing is we're learning how to correctly analyze data, and we're learning how to correctly analyze data that we've collected and analyze data that's being presented to us. Okay. Some of the questions that we ask as we go through this questions are, who collected the data, right? Would that matter if this data had been collected by an antivirus company? Yeah, probably, right? You think they might have some sense of bias, right? So basically, is there an agenda or bias in who's collecting the data? Who's it collected from? How do they collect this from? From their users? Does that necessarily represent everyone in the United States? I mean, so a lot of times when we say who is it collected from, we need to make sure that the sample represents the population. An easy example of that is if I wanted to figure out how all college students felt about statistics. And at this point you're like, I'm on the fence, I know. But if I want to know how do all college students feel about statistics, and I polled you guys, That would be really convenient. You're in my class, I could call, and you're like, well, no, of course we wouldn't represent everyone, and I'm going to be a little biased. I probably want to lie to you because I want to look good. That creates bias. Who do I collect the data from? Do you guys represent all college students across the United States? Definitely not. I mean, there are some special things. There's some special things about Porterville that make us different, right? But also, right, if I'm wanting to do that, could I then go, well, let's just sample everyone in Porterville College? Will that represent every college across the United States? No, no, it won't, right? So who's the data collected from? Let's keep going. What is the purpose of this study, right? Is their purpose to sell antivirus, right? How is the data collected is important, and we're going to be talking more about that, but the idea is that we're going to keep looking for biases, and let's see real quick. There's some good sampling methods. We'll talk about random sampling, simple random sampling, stratifieds, and I just put a list on there. There's some bad sampling methods. Voluntary response, convenient sampling. Voluntary response is where if I just took a poll, if somebody's walking down the street and I say, hey, can I ask you a quick question? Have you been hit by a computer virus? Right? That person doesn't necessarily represent everyone. So you got to be careful. If I let people volunteer. Convenience sampling is probably the one that I see the most on the internet. I love, some video games, and I'll go on some video game sites and they'll ask people, what's the best video game system out there? And they'll have a little window that I can click on and answer that. Well, that creates bias because what? I am choosing, if I'm choosing to respond, I feel really passionate about that. Anyone who's not passionate is not answering. And does their opinion matter? Yeah, of course. Just because they're not passionate doesn't mean they don't have a favorite system, right? Plus, what about the people that don't go to the website? Do their opinions matter? Well, yeah, if I'm trying to make a claim about everyone and what their favorite video game system is, if the company was to poll just their customers, that's convenient. They have their information. But do their customers represent everyone who owns a computer? So that's when we sample in a bad way, all of those create bias. We want to watch out for that. Okay. At this point, there's going to be some definitions. I'm going to give you a minute, to write these down. If you need to pause this, go ahead. But I'm going to kind of talk through these while you write them down. Data. Data is what we collect. It's a collection of observations, measurements, gender, race, survey responses. Just for fun and giggles, I think it's interesting that the singular of data is datum. So if I have a single piece of data, it's called a datum. It's kind of stupid, but I think things like that are cool. Statistics is when we experiment or we evaluate on data. Okay? So people present data, we run statistics on it, we can evaluate that data. We collect data, we run a survey, we can write a conclusion. That's statistics. Whenever we experiment or evaluate data, we are doing statistics. The goal of statistics is we want to infer. We want to draw conclusions from the data. We want to be able to make claims. We want to be able to prove things. We want to be able to make connections, right? So, that's what without bias is the key, though. And so there's going to be things that we're looking at to try to minimize the bias. And I honestly, I've talked to people who've told me, man, they really feel like this first chapter, students should just go through, write the definitions, do the homework, and they'll learn it. I like to talk to you guys about it. I think that makes a little more of a connection. But in all honesty, go through the homework. I do my best to prepare you for the material that you're going to see. The homework does a really good job at kind of reteaching you some things too. So kind of see how that works. But get these definitions down. The good news is I already told you can have a note card on the test, so you can write down these definitions. I'm not going to be asking you to define things, probably. I'm going to be asking you to apply them. Anywho. Hopefully that was enough time to copy down, I would say, up to here. And if not, you might want to pause it. The population is the group that we sample from, or who we infer or make a claim about. Who are we trying to represent? We have a larger group, right? If I wanted to know what the students of Porterville felt about, our new president, well, then the population would be all the students of Porterville. That would be the larger group. The sample is kind of who we actually collect data from. It's a smaller group from the population. So that might be me taking all the students of Porterville and randomly selecting 300 students and asking them what they feel about something. then that smaller group that I actually collect the data from would be my sample, the smaller group, okay? Let's see, let's scoot this down. Oh, just for fun and giggles, a census. This does pop up. They don't have it in the book here, then they but it's just something you should know. A census is whenever we attempt to collect data on an entire population. We do this in the United States. It's really expensive. It's kind of difficult, but we want to know kind of all when we make statements about the races, the race proportions in the United States, or the obesity rate, or pregnancy rate, or how many children per family and income per household. And how did they get that information, right? Well, a couple ways. They send that information out to houses, and people then will choose to respond. That's a potential bias. They choose to write in those answers and send it in. But if that's all we did, that wouldn't be right. That wouldn't really be a census. So what we do is we see the people that we don't get the information back from, and we maybe, start calling and asking that information. Is everyone going to answer the phone? Shoot, does everyone have a landline nowadays? No, right? You're not going to reach everyone. So what do? Well, we start doing home visits. We start going to those homes, and everyone who's kind of a registered voter, we start going through and trying to collect that data. We go house to house, and we take all that and we compile it, and we try to get as much information about as many people as possible. Does that represent everyone if I go house to house? What about people that are homeless? Do they matter? Absolutely. They're part of the entire population of the United States. So literally, people get hired to go kind of up and down streets and find some homeless people and try to collect the data. Do we actually ever collect the data from everyone? No. But we try to collect the data as much as we can from everyone in the entire population, and we call it a census. Very expensive, but very important. When we do a census, we actually make huge changes across the education field. Oh my gosh, look at the education rate and look at what we're doing. We need to change this. Money gets redirected into groups maybe to help with poverty, it's a huge deal. So, all right, that should have been enough time. Some principles of statistical thinking, okay? So when we run a statistical test, and we are actually not doing this for a long time, this chapter just introduces, it basically gives you kind of a peek of the next 13 chapters, okay? We're going to learn how to prep. What do we want to collect? What is the information we want to collect? From whom do we want to sample? The key here is what, right? Right, we want the sample to represent the population. Let's see. And then how do we collect it? And we've started talking about that a bit, that we don't want to create bias by sampling incorrectly. There are correct ways to sample, and there are incorrect ways to sample. Once we have that, we collect the data, right? We prep it, we collect the data. How do we analyze it? Graphs. We're going to be doing that, and I think by second chapter we're going to be looking at graphs. We're going to be starting to explore it algebraically. That's going to be like chapter 3, 4, 5. And then we're going to start applying statistical methods, and that's running actual tests and drawing conclusions about the population. So, I mean, and you're going to see all of these different types of things in your life. People will represent graphs, or they'll give you an algebraic analysis and throw it out at you, or they'll have like the conclusion of a test. And if you're not educated about statistics, you just accept things as true. And really that would be a scary thing to do. And then last, after we kind of have all that data, then we write our conclusion. Then we look at this and we go, what can we say from this analysis? What is it we can actually, fill in and say? Okay. Keep in mind the source of data, check for bias, right? And then the chapter section is going to do a really good job of just kind of exploring different, hey, we sampled, if I was to sample this class, would this class represent just this class? Would it represent all Porterville students? Right? Some of you may be like, yeah, I mean, we're a good group. We got some old people, some young people. It's pretty good. Well, you're all here, some of you are here at 8 in the morning, some of you are here in the afternoon. Aren't there some evening classes? do you think that they might be a little different? There might be a reason that those people have to take evening classes instead of morning classes or afternoon classes. So you may differ in some way that's going to change our answers. So we don't necessarily think this class would not represent all Porterville students. Okay. Also, we're talking about, sample size. We want to make sure that we get a large enough sample, but you'd be surprised how large of a sample you need. We could probably sample 200 students. If we did 200 students randomly at Porterville, we actually probably could represent all Porterville students pretty well. So keep that in mind that, we don't need a huge sample size to be able to make inferences. A small group can make pretty strong claims about a population. We're going to learn that more as we keep going. Also, look at the sampling method. Check for bias. Did they sample just a small group? Did they sample a smaller group because it was convenient? Did they sample, so this is all we're saying on these. And the homework does a good job about kind of setting up different situations and then saying, is this biased? Would this represent the population? Those types of questions. Okay, let's keep going. Section 1.3, types of data. So if we have two things, parameters and statistics. Parameters is when we have any information about the population. Statistics is where we have any information about the sample. The convenient way to remember this is parameter starts with a P, population starts with a P. Populations would be parameters about the population. That could be the population mean, or mu. That could be the population standard deviation. You don't know what standard deviation is probably yet, but I'll just do standard deviation, sigma. I could also do the population size. I could do, if we have a census, we have information about the population. Population size is big N. Statistics, S, information about the S sample. If I did a sample mean, we use an X with a bar on it. X bar is how we write that. If I do the sample standard deviation, you don't need to know what these are yet. I just want you, but we use just a lowercase s. And if I just do the sample size, that would be lowercase n. That's the difference. Anytime if I have information about the population, we call those parameters. If I have information from just specifically the smaller group, the sample, we call that a statistic. Here's an example. We sampled 1,500 students from 23,000 Porterville College students and collected their weight. They're like, okay, there's a number right there. What's that 1,500? Is that from the population or is it from the sample? Well, there's a keyword there. We sampled 1,500 students, so that 1,500 would be a statistic. From, what's the 23,000 Porterville College students? That's the big group, right? That's the big one. That's the entire group. That would be the population size. That would be the parameter. There is one other piece of information here. You're like, I don't see another number. You're not going to see you're not always going to see numbers in statistics, right? When I say I collected their weight, that is data. The question is, would it be data from the population or from the sample? Well, is it the weight of the entire population? Or is it the weight from our smaller group, from our sample? Well, we collected it, so we collected it from the sample, and if it's from a sample, that makes it a statistic. Discrete data is where we have countable values, finite or whole numbers. So if I said, how many brothers, how many sisters do you have, how many siblings do you have? Nobody in here has 3.2. You're like, well, my mom's got another one on the way, so it's only 0.2 of the way done. No, it doesn't work that way, right? So whenever I have a finite, or if I said, ranking, if I had, first place, second place, third place, you're not going to have, 1.5 place. How many toes do you have? Hopefully you don't have half a toe, right? So the idea is that anytime I have a number that is finite, you cannot have decimals or fractions. We just call it discrete. Feel free to pause this if you need to. I'm going to just keep scooting this down though. Continuous data is where we can have decimals or ranges. Basically, you have an infinite number of possibilities. For example, what if I said somebody's weight? We collected that on people, right? And you're like, I am, 187 pounds. Are you exactly 187 pounds? Or are you like 187.13? See, weight ranges, doesn't it? Every day you get up and it can increase or decrease. We measure it to the nearest pound, but the idea is that that weight itself ranges. There are an infinite number of possibilities between 187 and 188. There's decimals, there's all kinds of crazy, distances we could go with that. I could do ranges of weight, so you could have between 182 and 183. There are an infinite number of possibilities in that range. When we talk about time, if I measure seconds, right, that seconds can go to decimals and fractions, and so they can be continuous. Height, your height, right, it grows, it shrinks, it grows to a point, and you get older and it shrinks to a point, but the idea is that it has got a continuous change between the two. So that's discrete and continuous. What we're going to do now is I'm going to scoot this down to categorical data. Let's see. Categorical data is where we generally have categories. They're usually not numbers. We call this qualitative data. Okay. I get scared of this idea of qualitative because qualities are definitely categories. Like your race, your gender, your hair color, the color of car you drive. Those are all qualities, right? So in that situation, you're like, yeah, of course that's a category. Say, those are actually called nominal. A nominal categorical data is where it has no value. Ooh, some of you just got mad. You're like, oh, my race has a value. No, wait. Is one race better than another? And we go, no. Races, they're different, but there's no, you can have your intrinsic value and how you believe about it, but there's no, oh, this is greater than that or less than that. If you want to get into science and do, pigment ratios and all that, that's not what we're talking about. If I talk about gender, right, is male more than female? No, it doesn't work that way. It has no value in and of itself. You take a value, you take a meaning to it, but it's a quality, right? So we actually put some examples here. We said race, gender, any colors generally, okay? Ordinal is where we catch people. See, ordinal are still categories, but it has a certain order to it. That ord basically gives us order to the quality. So when I add order, that could be like your grade, right? You have A, B, C, D, and hopefully nothing below C. But the idea is there's order to it. Is A greater than B greater than C? Yeah, definitely, right? But is the distance from an A to a B the same as a B to a C? You're like, well, yeah, it's 10% difference, right? You went over that earlier. Well, not always is it. Sometimes I have a student that has a 90.2%, and I have another student that has an 89%. So there might be a 1% difference between an A and a B. So even though there's order, one is greater than the other, you don't necessarily have that equal spacing between them. Whenever we have placement, for those of you who are in sports and like to race, if I have first place, that was weird, give it a second, place, I don't know. If I do first place, that was weird. Oh, now it all appears fun. First place, second place, third place, right? Is there order to that? Yeah. First place is better, it's first, second and second, third. There's order to that. But is the distance between first and second the same second to third, third to... No, there may only be like a tenth of a second between them, and then there might be another minute till somebody comes in. So the idea is that there is still order. Now keep this in mind. I just put a 1, 2, and a 3. Those are numbers, aren't they? So categorical data, where we can get people in trouble, is where we talk about they are a number, and we're like, oh, well, that's a quantity. No, not necessarily. Not if it's a category. Not if it just has order. Okay, I'm going to leave that at that. Where we get quantitative data is where the data is basically always numerical. Always numerical. Interval basically adds equal intervals. So what did we just say earlier? Placement, right? Placement was ordinal. Now, what if I actually put the the race time? Then I could actually see first, second place, but I could actually measure the distance between the race time. If there were 3 seconds difference, 3 seconds would have meaning. So whenever you get that equal intervals, this is where you get your weight. This is where you get your height. And I don't know why this is going to act up, but I'll just wait. Okay. This is where you have equal intervals. The distance between 1 foot and 2 foot is the distance between 2 feet and 3 feet, right? You get those equal intervals. Another way that they explain this, which I think is kind of, at first I was on the fence, but I can really see some meaning between this. You can meaningfully add or subtract. So could I take the race times and subtract them and get a meaningful distance between them? Yeah. If somebody was 2 minutes 10 seconds, the other was 2:05, you could say, oh, that's 5 seconds between them. I could subtract them. Right? Could I add the times together? Yeah, maybe they were doing a race where they're, passing the baton, so you add the times, figure out how long it's going to take them to work together. So whenever I can meaningfully add or subtract, right? Can your weight meaningfully add or subtract? Yeah, unfortunately, it meaningfully adds all the time. The work is trying to meaningfully subtract it. Your height, you can take somebody's height and somebody's taller, and you could, add them, put one on top of the other. It's kind of awkward, but you do that in the pull and play. You could subtract them and make the short guy feel bad, or just there's things you can do, meaningfully add or subtract. Okay. Rational is where we get ratios. The big key feature on this is where you get a lot of your decimals and your fractions. Okay, decimals, your fractions. Give it a second. Okay, we get ratios. Okay, one of the key features here is that we have an absolute. I assume that's going to show up later. Deep sec. Apparently I gotta get an old priest and a young priest to look at this. All right, have an absolute zero. There we go. Weird. Okay, so decimals, fractions, we have an absolute zero. This is why we don't put weight down here. Can you measure a weight of 0? Right? Now you can get into the sciences, and this is where you go up and you talk about, your mass. Right? Your weight actually changes depending on what, it's like the gravitational pull, but if you could have a mass, something could have, a mass of 0 is an absence of it, but your weight cannot be 0. The weight is the gravitational pull. Time, depending on the situation, can have a meaningful 0, so sometimes time can go down here. Height, can you have a height of 0? Not really, so that's where you kind of lose that. This can get a little confusing, but the big difference on this is, and I love this, you can check if you can meaningfully multiply and divide. The question I like to ask is, can you have twice as much? Can you have half as much? Can you have half as much? So when I look at this and I say, okay, when we're talking about weight, can somebody weigh twice as much as you? Can they weigh half as much as you? Yeah, then that would probably go down here. Can somebody take twice as long, half as long? Yeah. So where I can catch a lot of people on this, and this is just interesting, I'm not trying to catch you on this, but temperature. Your temperature, right, is interval. Temperature in your body, the temperature, godly and temperature outside. This is temperature if we are doing degrees Celsius, degrees Fahrenheit, right? Those are all interval. You're like, why are they not rational? Well, can you have 0? You're like, yeah, it's 0 degrees. Yeah, but is it meaningfully 0? Is 60 degrees twice the temperature of 30? So you're like, I don't know. But my science people are going, no. 60 degrees is actually not twice as warm as 30. It doesn't work that way. I can meaningfully add and subtract and find the difference in the weather, right? But 0 degrees Celsius, 0 degrees Fahrenheit does not mean 0 temperature. Temperature can be rational. Here's where my science people, right? That's where I have degrees in what? Those are our kelvins. That's where I basically say a Kelvin value of 0 means that there is an absolute lack. 0 temperature, 0 movement, 0 energy. That's the difference, okay? I like to introduce this. You're going to have some of it in the homework, some of it on the quizzes. I'm not going to ask you to separate this on the test. I'm just going to tell you right now, and I'm not, like, then why are you bringing it up? Well, because it is important. I find that people have a really big issue with this one. And whenever they see a number, they'll just call it quantitative. And so by kind of going through these 4, you really learn that if something doesn't have equal intervals, you're like, no, it's really just a category. And so you throw it up there. So it really will help you understand the data a little more meaningfully. But when we get to the test, I'll be asking you if it's categorical or quantitative. The homework's going to ask you to go a little deeper. And that's good. It doesn't hurt you. But I think that's a good way to learn it, but I don't think it's something I need to necessarily test you on. All right, let's go through just a couple of examples. Determine if the value is a statistic or a parameter. Among all the teachers, and I think they're specifically talking about the numbers on these, right? Because I could say all the teachers and then go, that's a parameter, because we're talking about all the teachers. But they said among all the teachers in the math department, 34% are female. Is that a statistic and a parameter? Well, a lot of people are like, well, it's a statistic because it's a small group. Well, here's the key word. This 34% is data from the entire group. So because that is from the entire group, we would designate that as a parameter. See, if my population was all the teachers at Porterville College, I could find the percent that are female. That would be a parameter if that's my population. If I just took a sample of 10 teachers and then I used that to find the percent that are female, that would be a statistic. So if I took a smaller group, but this is the entire group. I know you're not feeling warm and fuzzy anymore. A sample of 35 randomly selected homers have an average monthly income of $2,000. What is that? Well, there's a keyword there that made it easier. It's from a smaller group. It's not all of them. It's from a sample. And if it's from a sample, that makes that a statistic. In fact, it also makes the 35 a statistic because that would be our sample size. Rebecca recorded the number of hours she watched TV each day for a week, and the average was 6.2. So her average is 6.2. I don't see her inferring anything from a larger population. It's about, she's not like an individual from a larger population. I'm going to call this one a parameter. I'm on the fence. I'll do this. She recorded a number of hours for a week. You know what? I'm going to say, sorry, she recorded it for a week. And if we're going to say that that week is supposed to represent all of the TV that she normally watches, then this would be a sample statistic of the time that she watches TV over multiple weeks. That's her average per week. I'm going to change my mind and call that a statistic. Sorry about that. Average annual salary of California state senators is, what is that? Is it a smaller group or is it, right? Well, the California State Senators, this is their average of the entire group. If it's an entire group, that makes it a parameter. Okay. And last but not least, classified data by type. Oh, I forgot to change this. I live in Bakersfield, so population of Bakers Porterville. All right, Porterville. If I did the population of Porterville, would it be, what type is it? Well, would it be rational? Is there a meaningful zero? Now you're like, yeah, you can't have zero population. All right, then this is where I go, could you have twice as much, half as much? Could there be a place that has twice the population, half the population? If that is true, then that makes it rational. That also makes it quantitative, right? So when you do the classify by type, I'm going to go back real quick and show you. Start at the top and go, is it rational? No, that's the bottom of my page. Is it rational? No. Then is it interval? No. Then is it ordinal? Then is it nominal? So kind of start at the rational and see if it fits the requirements, okay? The reason why I call this rational is could you have 2 times the population or half the population? Yeah, easily, right? The models of 4 trucks. Well, that's not even a number, right? If that's not even a number, then it's not rational, it's not interval. If it's not even a number, I know it's going to be categorical. So what I need to do is I need to now look at the top 2, the categorical. Does it have order? Or is it just nominal? Does it have no value? Is a Ford Flex greater than a Equinox? Does a Ford Fusion, right? Is that smaller, or is it less than, or is it? No, it doesn't work that way, right? They're just oh, I said trucks. I should read. I should read better. Apparently, I don't know my trucks. But those are categories with no value, so that makes them. They're just names. They're just categories. The high temperature for the day. Well, I assume it's 100 and hell today. So what's the temperature? Well, I definitely know that's a number. That doesn't make it quantitative. But I'm going to start at rational and go, is that high temperature? Can you have, if it's 102, would 204 be twice the temperature? No, it wouldn't. So that means it's not interval, or it's not rational this time. Is it interval? Well, is there an equal interval? If it's 102 today and 90 tomorrow, could you meaningfully subtract those and find the difference between them? Yeah. And if you could, then that makes it not rational. What is it? Interval. You can find the difference between the high temperature today and the low temperature for today, and it has a meaningful distance between them. You can add or subtract them, okay? Interval, I'm going to go back and do discrete and continuous in a minute, okay? Okay, the cost of a new home. I'm thinking number, right? So I'm going to start at rational. Can you have a meaningful zero? That's a weird question. I didn't like that when I read that in a book. So what I like is what this book says. Can you have twice as much, half as much? Can you meaningfully multiply or divide? Could a cost of a home be twice as much? Yes, if you're at the beach, right? So I know that it's going to be numerical. I know that it's going to be quantitative. I should have put that on the last one. Quantitative. Quantitative. But if I can meaningfully multiply or divide, if I can have twice as much or half as much, then that makes it rational. Okay. Now the question is discrete or continuous. So I only really need to look at these 3, because they are the quantitative ones. Is the population of Bakers Porterville, right? Discrete or continuous? Can I have 1,000,000.5 people? Can you have a decimal? If you can, we'd say continuous. If you can't, we would say discrete. Is the temperature discrete or continuous? Can I have 0.5 degrees? Yeah. In fact, what is it? Our body temperature is what, 98.5, 98.6? That makes it continuous. There's an interval or a range between them that makes sense. That makes this a continuous. Is the cost of a new home discrete or continuous? I'm on the fence because I know it's not going to go beyond a penny. I check this when you get to one like this. I would still call this continuous. They might call it discrete, but I'm thinking of it as continuous because you can have, cents, and especially when we're doing interest and all that, you can have decimals of a percent. I feel pretty good about that. But the book does some weird things, and I do some weird things, and that's kind of the fun with statistics. Is that I've taught out of 4 or 5 different statistics books, and they don't all cover things exactly the same way. And that's okay. There's a little bit of wiggle room in it. But go through the homework. It's not too bad. And come back in a couple days ready for the test. Thank you very much.